Welcome to this lesson on solids, liquids, and gases. In this presentation, we will explore how matter behaves in different states, what happens during changes of state, and how temperature and pressure affect gases. Let's begin with the distinguishing properties of solids, liquids, and gases. There are three states of matter. These are solid, liquid, and gas. Solids have a fixed shape and volume. Liquids have a fixed volume but no fixed shape. Gases have neither fixed shape nor fixed volume. In your exams, always write both shape and volume when comparing the three states. In solids, particles are closely packed together. They are held by strong forces of attraction. They vibrate in fixed positions but do not move freely. This is why solids are rigid and incompressible. In liquids, particles are still close together but can slide past each other. The forces of attraction are weaker than in solids. This allows liquids to flow and take the shape of their container. Exam tip: remember, liquids are not compressible because their particles are still close together. In gases, particles are far apart. They experience very weak forces of attraction. They move freely and quickly in all directions. This explains why gases can spread to fill any available space. Always remember, the difference between liquids and gases lies in compressibility. Gases can be compressed, liquids cannot. Let's practice some IGCSE question on the states of matter. The diagram shows the three states of matter for a substance. Each circle represents a molecule of the substance. Question I asks us to complete the diagram by drawing 6 circles to represent molecules in the gas state. Question I asks us to pick the correct statement. Question I says which term is used for a solid changing to a liquid. You can pause the video and give it a try. Here are the answers to the questions. A heating curve shows how temperature changes as a solid is heated. Notice the flat sections of the graph. During melting, the temperature stays constant while particles break free from fixed positions. During boiling, the temperature again remains constant while particles gain enough energy to escape into the gas phase. When drawing the heating curve, always label flat sections of the graph as state changes. Let's take a look at the cooling curve. A cooling curve is the reverse process. The flat sections show condensation and freezing. Here, energy is released as particles slow down and form stronger bonds. Let's practice some IGCSE question on heating and cooling curve. The diagram shows a heating curve for a sample of compound X. Questioner: is X a solid, a liquid, or a gas at room temperature, 20 degrees Celsius? Question B. Write an equation for the equilibrium which exists in region BC. Question C. Name the change of state which occurs in region DE. Question D. Explain how the curve shows that a pure sample of compound X was used. You can pause the video and attempt the questions. Here are the answers to the questions. Pause and study the explanations. As temperature increases, gas particles move faster. They collide with the walls of the container more often and with greater force. This increases the pressure if the container is fixed. If the container can expand, the volume of the gas increases. Increasing the pressure on a gas pushes the particles closer together. This reduces the volume of the gas. Exam tip: remember the relationship. Pressure is inversely proportional to volume if temperature is constant. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with ACE students. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.